So now we look at the algorithm that does this decomposition of a simple polygon into a bunch of monotone polygons. The idea is to use sweep line algorithm. Similar to all sweep line algorithms, we must have an event queue and we must have a bunch of events. But in this particular problem, the events are kind of static. In other words, the only events that exist in our sweep line are the vertices of the polygon. So therefore, we don't even need a priority queue to do this. We can just sort the points based on the y-coordinate, because our sweep line again will start from y plus infinity and will go down. And after sorting the points, we can just run a for loop where we handle the ith point because there are no other events, right? So that essentially replaces the priority queue. But we still need a data structure to maintain the status of the sweep line. If you remember in the line segment intersection problem, if my sweep line is over here, I wanted to maintain the set of line segments that intersect the sweep line in the correct order from left to right. Here I want to keep a bit more information. Okay, let me explain what do I mean by this. So imagine that the sweep line is over here. I have these 4 line segments intersecting it. So therefore I can decompose the sweep line into 5 intervals. This interval, which will be outside the polygon, this interval, which will be inside, this interval, which will be outside, this will be inside, and this will be outside. Okay. In general, if you draw a line, it will intersect the boundary of the polygon an even number of times. So therefore you will have an odd number of intervals created by those intersection points. The first and the last one will be outside, and then you will be alternating from outside to inside. As you go here, you are out, in, and then out. What we're interested in are intervals that are inside the polygon, because we really don't care about what's happening outside the polygon, right? So I want to maintain these intervals. Before reading what these guys mean, let's see what happens when I sweep a line downwards, and what happens to this inside interval. Okay, sweep line starts plus infinity. There is nothing, there is no intervals. As soon as I touch here, I see an interval. So this interval grows. At this point in time, suddenly a new interval appears. So now I have 2 intervals. So these intervals grow. They change shape, as you can see. So this interval used to slide against this edge, then it slides against this edge and this edge, then it slides against this edge and this edge. And then at some point they might merge. So now I have 1 interval. At some point they might split. So now I have 2 intervals again, and so on. So as I sweep down, lots of things happening to these intervals. They change shape, they might split, they might merge, new intervals might appear, intervals might end. So at this point, if my sweep line gets here, at this point the 1 interval will simply disappear, and so on. For every edge of the polygon, I keep track of which interval they bound. Every edge of the polygon will only have 1 interval adjacent to it. Like for example, this edge has only 1 interval that is inside of it, because this part will be outside, right? So clear this. So in this picture, this edge of the polygon should point to that interval, that edge of the polygon should point to that edge should point to this, and that edge should point to this. In general, every edge of the polygon that intersects the sweep line will have 1 interval that is inside, right? So if this is the edge of a polygon, either that interval should be inside and the other one should be outside, and you keep a pointer to which one it is. Okay. And finally, for every interval, I want to maintain what is the lowest vertex that I've seen so far. What do I mean by that? For example, look at this interval and now walk backwards in time. So before this interval was like this, before it was like this, etc., etc. there would be a point in time where this interval has met a vertex that lies around its boundary, and that is the lowest. I want to remember this. What is the lowest that I've seen? So for example, in this picture, that would be the lowest for both that interval or that interval. But if, for example, my sweep line reaches here, my sweep line is over there, then the lowest that I've seen is going to be that point and that point. Because if I walk backwards in time, if my sweep line is at this position, if I go backwards in time, the first point that this interval will see at its boundary is that point, where this guy will not see that point and will still remember that point as the last point that it has seen. Okay, and those are the pointers that I want to maintain during the sweep line algorithm. Okay, and then in the next video we're going to look at the details of the sweep line algorithm and how to maintain these pointers.